Hello everybody, today I'd like to continue Ohm's law. So in our last lecture we talked about the Ohm's law, V equal I times R. As you know that the Ohm's law is the relationship between the potential difference, current and the resistance. Okay. So today let us continue the Ohm's law and the application of the Ohm's law. We already discussed the resistance R, which is R, this is equal to rho L divided by A. Here R is the resistance, L is the length of the conductor. Okay, so if you have a conductor like this, okay, so L is the length of the conductor and A is the area of cross section, this area, this is your A, and rho is the resistivity of the material. So the resistance depends on the this rho also, I mean the property of the material. So different conductors, they have a different resistivity. Okay, so this is a constant, but here this is the resistance which opposes the flow of current. So the resistance depends on length of the conductor and the area of cross section of the conductor. So if you have two conductors, like let's say this is copper and its length is 20 centimeters, and if you have like iron and length is again 20 centimeters, the resistivity of copper and iron is different. Okay, so rho is different. So copper has a one resistivity, iron has the another resistivity, and of course you get the different resistance. But if you take another, like let's say 10 centimeter long iron conductor, iron wire like this, iron rod. So if you measure the resistance of 20 centimeter long iron rod and 10 centimeter long iron rod, you get the different resistance, because resistance depends on length. Resistance depends on area of cross section. But if you measure the resistivity, iron and iron, they are the same material, so the resistivity is same. We already talked about it, but today I want to discuss what happens if you combine two or more than two resistors in series and in parallel. Okay, so let us do the series and parallel combination of resistors. Okay, first I would like to do the series combination. Okay, let us consider you have two resistors having resistance R1, and we have another resistors having resistance R2, and they are connected in series. So R1 and R2, two resistance here, and I would like to connect in a series. So here is the circuit diagram. This is the switch, okay, and here I want to connect the source. This is positive terminal, this is negative terminal. Okay, so this is the circuit diagram. Right now the circuit is off circuit, no current is flowing through the circuit, but I want to make it closed circuit. So the current flowing through the circuit is, let me call I. I is the current passing through the circuit. Now look at this combination R1 and R2, okay, they are connected here, and this current is passing through R1 and R2. There is no junction here. That means the same current is flowing through each resistor. There is no division of current in this case. So if there is no junction, that means there is no division of current, and that combination is called as the series combination. Therefore, in series combination, there is no division of current, but the potential drop here across these resistors, let me call V1, and the potential drop here, let me call V2, they are different. The same current is flowing through each resistors, but the different potential difference across each, drop across each resistors. Okay, so let us suppose the total potential difference, the source, the potential difference of the source is V. Then what happens is this potential difference, the V, this must be equal to V1 plus V2. What is V1? V1 is the potential drop across R1 and V2 is the potential drop across R2. And in this case, this is series combination, same current is passing through each resistors. Okay, if R be the total resistance of the circuit, R is the total resistance of the circuit, and let us suppose I be the total current. Then we can use the Ohm's law. The potential difference V equal to IR. Okay, so now this equation it becomes IR, this is equal to, here you have a V1, so you can write down IR1 plus IR2. So V1 is IR1 and V2 is IR2. I put I and I there because the same current is passing through each resistors. There is no division of current here. Okay, so IR equal to IR1 plus IR2. Then if you simplify this, you get IR, this is equal to I times R1 plus R2. Then from here you get total resistance R equal to R1 plus R2. Therefore, if you combine two or more than two resistors in series, the total resistance is sum of the resistance of all resistors. So here I connected two resistors R1 and R2 in series. So the total resistance in the circuit R is equal to R1 plus R2. If you have a three resistors connected in series, then in that case you can also write down the total resistance R equal to R1 plus R2 plus R3 like this. So simply you add all the resistance together. And in this case, the total resistance R is greater than the smallest resistance in the circuit. For example, let us suppose if R1 is 10 ohm and R2 is 20 ohm. What is the total resistance of the circuit? Is simply use that formula, R equal to R1 plus R2, right? So your total resistance R equal to R1 is 10 ohm plus R2 is 20 ohm. So this equal to, the total resistance is equal to 30 ohm. You can see here, this is the total resistance of the circuit. So this is 30 ohm and the smallest one is 10 ohm, biggest is 20 ohm here. So the total resistance is greater than the biggest, the largest resistance in series combination. Okay, one more time, in series combination there is no division of current. Same current is passing through each resistors. Okay, and the total resistance is sum of the individual resistance then, R equal to R1 plus R2. And here the total resistance is greater than the greatest resistance. Here the greatest resistance is 20 ohm, but our total resistance of the circuit is 30 ohm. So it is pretty simple. Okay, and this is the series combination. Okay, and we have another combination, that is a parallel combination. Let us talk about that, then we can do the numerical problem. parallel combination. Again, let us suppose we have two resistors having resistance R1 and another resistor having resistance R2. We can use this is 10 ohm and this is 20 ohm, and if you connect like this terminal connect to these points, both terminals here, and these 2 points bring together like this and connect this to the source here. If you want, you can put the switch here, okay, but I want to make a closed circuit, so let me turn on this switch. So here I have two resistors R1 and R2, and this combination is called as the parallel combination. What happened here is, let us suppose this is positive terminal of the battery, this is negative terminal, and let us consider the potential difference is V, and as you know that the current is flowing from positive terminal to the negative terminal, so you can write down I is the current passing through the circuit, total current. And look at this, let me call this point is A and this point is B, or simply I can call terminal A and B. So if you measure the potential difference here, if it is, for example, let us suppose 9 volt, if you plug the two needles of the voltmeter here, you get a 9 volt. Or if you plug the two terminals, I mean two needles of the voltmeter here, you get the same voltage, 9 volt. Or if you plug here or there, you still get the 9 volt. This means the potential difference across these resistors or across these resistors R2 or here, you get the same potential difference. Okay, but look at this point A, this is the junction. Now if you have a current I here, but at this point what happened, the current is divided here. Let me call the current here is I1 and here I2. This means if there is a division of current, that combination is the parallel combination. Okay, so in parallel combination, there is division of current. But here you have the same potential difference across each resistors. Different current passing through each resistors, but you have the same potential difference across each resistors. So total current in the circuit is I here. This is the total current, and here this is the current I1 which is passing through R1, and this is a current I2 which is passing through R2. So this is I1, here you have I2, they added here and you get again I. Okay, so the total current here is I equal to I1 plus I2. What is I? I is the total current in the circuit, and I1 current passing through the R1 and I2 is the current passing through R2. So if you add I1 and I2, you get the total current. Very simple, right? Then if R be the total resistance of the circuit, if R be the total resistance of the circuit, then we can use the Ohm's law. So what is I? You know V equal to IR, this is from Ohm's law. So what is I then? I equal to V divided by R. So this I is the total current. So I can write down I equal to V divided by R. This equals, what is I1? I already mentioned that the voltage here, voltage there, and that they are equal. This is a parallel combination. So you can write down this is V divided by R1 plus I2. This is also equal to V. You have the same potential difference. So write down V divided by R2 then. Okay. So this is V divided by R. This is equal to, I have a V here, I have a V there. So I can pull out. So V times 1 over R1 plus 1 over R2. This V and this V I can cross out. Then this gives you 1 over R equal to 1 over R1 plus 1 over R2. Or if you want to simplify this, the total resistance in the circuit R, this is equal to R1 times R2 divided by R1 plus R2 then. So this is the total resistance in parallel combination. This is the total resistance in parallel combination. So again, in parallel combination, you have the same potential difference across each resistor, same potential difference, okay, please don't forget. And you have a different current passing through each resistors. That means the total current is the sum of the individual current, I1 plus I2, if you have a two resistors like this. And what happened, let me show you. Here I have a total resistance in the circuit is R1 times R2 divided by R1 plus R2. Then in this case, if R1 is 10 ohm and R2 is, let me make a change, let me make it 20 ohm, okay. Then we calculate the total resistance here then. Of course, we can do this easily. I have a two resistors here. R1 is 10 ohm and R2 is 20 ohm. Then the total resistance is R equal to R1 times R2 divided by R1 plus R2. So if you plug the number, R equal to R1 is 10 ohm, R2 is 20 ohm. Divide this by R1 10 ohm plus R2 is 20 ohm. So if you use your calculator, I don't have a calculator here. So DC is, how much is this? And this is 200. Divide this by 10 and 20, it is 30. 1 ohm cancel out here, so you have simply the ohm. So it is 20 divided by 3 ohm, roughly it is 6.66 ohm. Okay, now look at this. We have a two resistance, 10 ohm, R1 is 10 ohm and R2 is 20 ohm. And I calculate the total resistance of the circuit. And the total resistance in the circuit is 6.66 ohm. So, from this calculation, you can easily say that the total resistance in parallel combination is decreased. And here, the total resistance is less than the least resistance, the smallest resistance. The smallest resistance here is 10 ohm. But the total resistance from our calculation, we got only to 6.66 ohm. So, in parallel combination, the total resistance is less than the smallest resistance in the circuit. Okay, so this is the parallel combination. So we have a series combination, parallel combination. How do you wire your house? You simply, you have a parallel combination, parallel wiring in your house. The reason is like if this is your living room and if this is your kitchen, you don't want to use the power at the same time. Like if you want to turn off the power in the kitchen and if you need a power in the living room. Okay, so in that case, you can keep the one switch here, keep one switch here and keep another switch there. Okay, so if you need a power in the kitchen, you can turn on this switch. If you need a power in the living room, you can turn on this switch. If you need a power in both rooms, of course, you have to turn on both switches. But if you keep the switch just here, if you turn on these, then there will be power here and there. We don't want that. So simply we do the parallel wiring in our house. Okay. So this is the series and parallel combination of the resistors. So mainly you have to memorize the certain formulas here, okay, to solve the numerical problem. So the importance formula are just simply you can write down P equal to IR, which is Ohm's law, and if it is a series combination, you can write down R equal to R1 plus R2. If it is parallel combination, you can write down 1 over R equal to 1 over R1 plus 1 over R2, or this one you can write down R equal to R1 times R2 divided by R1 plus R2. Okay, So you need these formula. We have more, but these are the kind of important formula we need. So let us do one problem using these formulas, okay? Let me draw one circuit, okay? Here is the problem. Let me call problem number 1, and I want to draw the circuit. Let me call this is R1, which is 2 ohm, okay? And right here I have R2, which is 6 ohm, and here I have R3, which is 12 ohm, and this is connected to the, I want to keep the battery here, and battery is 12 volts, okay, and connect this. Now the question here is, what is the total resistance? What is total resistance? What is this? Okay, and we can also calculate what is total current. Okay, we can also calculate what is V1, what is V2, what is V3 also. We have a R3 there. What is V3? And you can also calculate what is I1, what is I2, what is I3. Okay, so you have a circuit. This circuit, we have to analyze this circuit. Analyzing the circuit means simply we have to calculate the voltage here, we have to calculate the voltage there, we have to calculate the voltage here, and then we have to calculate the current here, we have to calculate the current there, and we have to calculate the current here. Okay, so to calculate the total current in the circuit, everybody, you always calculate the total resistance first. So the first thing we need to do here is, what is the net resistance of this circuit, or what is the total resistance of this circuit. So that is the first portion, first part you need to do. So how to calculate the total resistance then? Look at this. I have R1 here, I have R2 and R3. If there is a current here, let me call this is plus and this is minus, so the current is I. Now look, the current is passing through here this way, but there is no division of current. So here, let me forget about this right now. But right here, the current is divided. The current is divided. So this combination is parallel combination. Start the problem right from there. So first you have to calculate the total resistance of this R2 and R3. And R2 and R3, since there is a division of current, so this is parallel combination. So if it is a parallel combination, then we can calculate the total resistance R23. What is R23? R23 is the total resistance of this R2 and R3. They are in parallel. So this is equal to R2 times R3 divided by R2 plus R3. This is the total resistance. Right here only, not the total resistance of the circuit, just the total of these R2 and R3. Now plug the number. R2 is 6 ohm, R3 is 12 ohm, and divide this by 6 ohm plus 12 ohm, and this is equal to, how much is this? I don't have a calculator here, so this is, I think this is 72 and this is 18. So it is, I think, 4 ohm. Please make sure this number is correct, okay? This number is correct. So this is, the R23 is the total resistance of R2 and R3. Then your circuit becomes like this. You have R1 here, which is 2 ohm. Then we can replace this loop by R23. Now look at this. There is a current I. So if this current is passing through here, R1 and R23, there is no division here now. This means the R1 and R23, they are in series then. So we can calculate the total resistance of the circuit, which is R1 plus R23. Let me call total resistance is R is R123. We have to add this and this, so I represent by R123, and this is equal to R1 plus R23. So this is simply R1 is 2 ohm plus R23 is 4 ohm. So this is equal to 6 ohm. Therefore, the total resistance in the circuit is 6 ohm then. The total resistance in the circuit is 6 ohm. We get the total resistance in the circuit. So the total resistance in the circuit is 6 ohm. This resistance and these two resistance. This is a mixed combination. Okay, here you have a parallel combination, and this parallel combination is in series with this R1. So first I use the parallel combination formula, and then I use the series combination formula, and I get the total resistance in the circuit is 6 ohm, right? Now the next thing we need to calculate is what is the total current. We have a total voltage already. This is a total voltage. V is 12 volt. So the total current, we can use the Ohm's law, V equal to IR. Therefore your I is V divided by R. Total voltage is 12 volt, and the total resistance, we just calculated total resistance, which is 6 ohm. So write down 6 ohm. Then from here you get 2 volt per ohm, which is ampere. You can write down 2 ampere. Therefore the total current in the circuit I equal to 2 ampere. Okay, we calculated the total resistance R 6 ohm, total current I 2 ampere. But still we have several things to calculate. We want to calculate I1, I2, I3, V1, V2, V3. So how to do this then? First look here. I want to calculate the current here. This current is here, total current is I. So the I current is passing through here, but there is no division of current right there. So here if you want I1, I1 is equal to I, because there is no division here. So simply it is really straightforward. Your total current is I, but I1 equal to I equal to 2 ampere. The total current in the circuit is equal to the total current right there also, here. So if you know the current I1, can you calculate what is V1, the potential drop across R1? V1 is, you can simply write down I1 R1, and this is our Ohm's law. Okay, so your V1 is, I1 is 2 ampere and R1 is 2 ohm. So your V1 is 2 times 2, 4. It is a voltage, potential difference. So V1 is 4 volt then. Okay. So I1 is 2 ampere. V1 is 4 volt. Now we have to calculate what is V2, what is V3. But look, this voltage here and voltage there, they are equal because they are in parallel. I mentioned that if 2 or more than 2 resistors are in parallel, the voltage drop across each resistor is, they are equal. So potential drop here and there, they are equal. So if I can calculate this potential difference, which is also equal to this. So how can I calculate? Okay, look at this. The total voltage is, total potential difference is 12 volt. Okay, so the voltage drop here plus voltage drop there must be equal to 12 volt. Okay, so what is V2 then? What is V2? V2 and V3, they are equal because they are in parallel. So this equal to total voltage is V. Out of these 12 volt, 4 volt drop here, 4 volt drop here. So what I have to do is V2 equal to V3 equal to total voltage minus voltage drop across R1. So V minus V1. Therefore this is equal to V is 12 volt minus V1 is 4 volt. So this is equal to 8 volt. This is V2 equal to V3 equal to 8 volt. Or simply you can write down V2 is 8 volt, V3 is also 8 volt because they are in parallel. So these 8 volt plus 4 volt, if you add them, you get 12 volt. And this makes sense, right? The energy constant. Okay. So far we calculate total resistance, total current, we calculate the voltage across V1, we calculate the current passing through the resistance R1. Let me tell you again, here I think I made a mistake. The voltage across R1, not V1. I calculate the voltage across R1 which is 4 volt. We also calculate the current passing through R1 which is I1 is 2 ampere which is equal to the total current also. We calculate the potential drop here and there which is 8 volt. Now we want to calculate what is this I2 and what is this I3. We already know the potential difference here. So I can use this formula V2 equal to I2 R2. So what is I2 then? I2 is V2 divided by R2. Okay, so V2 is 8 volt and R2 is 6 ohm. So it is 8 divided by 6 ampere. I2. I2 is 8 divided by 6 ampere. Please use your calculator and you can write down in decimal, but this is still what? 8 divided by 6. Similarly, you can do V3 equal to I3 R3. So I3, this is equal to V3 divided by R3. V3 is again 8 volt and R3 is 12 ohm and you get 2 divided by 3 ampere. Okay, so this is one sample problem. Okay, always if you want to calculate the total current in the circuit, first you have to do that total current in the circuit. You have to calculate the total resistance. So to calculate the total resistance, there is no any straightforward rule. So simply look at the series and parallel combination. If the circuit is something like this, first I want to start from this loop. Okay, so I'll give you more problems to practice, but right now I want to stop here. Thank you.